Hey everyone, welcome to this explainer. Today we're going to demystify the invisible protocols that power, get this, more than 300 billion emails sent globally every single day. I'm really glad you're here because we're unpacking a piece of foundational internet technology that we all use probably dozens of times a day without even giving it a second thought.
Have you ever actually stopped to wonder how your emails magically travel across the internet the exact second you hit send? I mean, it feels totally instant to us, right? You finish typing, click that button, and boom, your message is just gone, popping up a second later on a colleague's screen halfway across the globe. But there's actually an incredibly powerful protocol working tirelessly behind the scenes to make that happen. It's not magic, it's a brilliantly designed digital system. And today we're going to break down exactly how it works.
So here's our roadmap for the explainer today. First up, the magic of send. Second, the digital postal service. Third, inside the SMTP conversation. Fourth, servers and relays. And finally, number 5, push versus pull.
Let's jump right into Section 1, the magic of send, unveiling the invisible hero.
We gotta start by naming the true star of our email delivery system, the invisible hero that honestly makes this whole thing possible. The protocol we're talking about is SMTP, which stands for Simple Mail Transfer Protocol. Now, at its core, SMTP is an application layer protocol. What that basically means is it defines the standard internet communication rules between servers and computer networks, specifically for sending emails. Without this universal set of rules, a computer in New York literally wouldn't know how to format or hand off a message to a server in Tokyo. SMTP provides that shared language.
So whether you use Gmail, Outlook, Apple Mail, whatever it is, SMTP is the invisible force pushing your composed message from your phone or laptop out into the digital ether. It's strictly designed for outgoing mail. It takes your text, the formatting, those heavy attachments, and it packages the whole shebang up using those standardized rules to push it out to the wider network.
Moving on to Section 2, the digital postal service, making sense of mail routing.
To really wrap our heads around how this works without drowning in technical jargon, let's map it directly to a system we all know, the traditional postal service. Think about writing a physical letter. When you finish it, you drop it in a mailbox, right? Well, in the digital world, hitting send in your email app, which is technically called a mail user agent or MUA, is exactly like dropping that letter in the mailbox. From there, a postal worker picks it up and takes it to your local post office. Digitally, your email client hands the message off to your local SMTP server, known as a mail transfer agent or MTA.
Let's trace the exact steps of this transit route. Step 1, your mail user agent connects to your sender's mail transfer agent. Then the real heavy lifting kicks in. Your local SMTP server acts just like a massive postal sorting facility. It uses the protocol to figure out exactly where the recipient's email server lives. And then finally, it routes the message right across the internet to its final destination. It's the exact digital equivalent of mail delivery trucks driving a physical letter from your local post office all the way across the country to the destination post office.
All right, let's dive into Section 3, inside the SMTP conversation, how servers talk to each other. Now that we have the broad strokes down, let's peek under the hood at the actual conversation taking place over a TCP/IP connection. This interaction doesn't just happen randomly out in the void. It happens on very specific network ports. Traditionally, SMTP used port 25, and honestly, this is still heavily used today, but mostly for server-to-server communication. However, when your personal email client is submitting a message to your server, security is absolutely paramount. Today, we primarily use port 587 as the standard for secure encrypted client submission. Or, sometimes you'll see port 465 used as an alternative secure port. Either way, this ensures your data isn't just flying out there in plain text for anyone to intercept.
Once connected on that secure port, the client and server literally talk back and forth. It's a fascinating and honestly surprisingly polite dialogue. The client kicks things off by saying, hello, literally HELO, like, hello, I want to talk SMTP. The server responds with numerical codes like 250 OK, basically saying proceed. Then the client says mail from, identifying the sender. The server says 250 OK, got it. Next is RCPT2, identifying who it's going to. Again, 250 OK. Then the client sends the data, so the headers, the actual body of your email, and concludes with a single dot, which just signifies the end of the message. The server replies 250 OK, message accepted. Finally, the client says quit, and the server replies with 221 goodbye, securely closing down the connection. This highly structured back and forth handshake, it all happens in just milliseconds.
Which brings us to Section 4, servers and relays, navigating different domains.
Now, the journey gets a slightly different technical distinction if you're emailing someone outside of your immediate local domain network. Say you're emailing someone at a completely different company. Your email must go through an SMTP relay process. By definition, an SMTP relay is the process of transmitting emails between SMTP servers hosted on different domains, all without modifying the message itself in any way. It acts as a critical bridge, spanning the gap between these totally distinct networks.
And this really brilliantly illustrates why security is so deeply baked into modern SMTP. Because this message is traversing the wild open internet, jumping from your server, acting as a relay, over to a completely different server on a different domain. SMTP servers utilize SSL or TLS encryption protocols. These protocols basically scramble the data, protecting your payload from being intercepted, read, or messed with along its journey.
Let's wrap up the technical side with Section 5, Push versus Pull, the boundaries of SMTP.
To really establish the boundaries of what SMTP does, we have to understand that it only handles one half of the email equation. SMTP is strictly a push protocol. It is exclusively used to send messages out, from your client to your server, and then from your server to the recipient server. But what happens when you want to read an email someone sent to you? Well, that's where entirely different protocols step in. Protocols like POP3 or IMAP are required to essentially pull those messages down from your receiving server into your email client so you can actually read them. So just remember, SMTP pushes out while POP3 and IMAP pull down.
To quickly summarize our journey today, SMTP stands as the essential digital postal service for the internet. It reliably pushes your outgoing mail across the web, relying on a strict client-server model over TCP/IP. It protects your data using secure ports like 587 or 465 for client submission. And it orchestrates that fascinating back-and-forth dialogue using those precise numerical codes we looked at. And of course, always remember its boundary. SMTP handles pushing emails out, and it leaves the job of pulling them in to POP3 and IMAP.
So, the next time you click send, will you picture that complex digital postal service instantly springing into action? It is honestly amazing to think that this intricate, invisible conversation happens flawlessly every single time you hit that button. All those commands, the secure ports, the relaying across domains, it all happens in the blink of an eye to connect you with the world. It really makes you wonder, what other incredible digital magic is hiding in plain sight, right under our fingertips? Thanks for joining me for this explainer. I'll get you next time.